Delhi is a city anchored deep in the past. People have lived here continuously since the 6th century BC, and local legend claims it as the ancient capital of the Pandavas in the Mahabharata. By 1857, the city fell under British rule. In 1911, the colonial government shifted their capital here from Calcutta, establishing a sprawling administrative hub. For centuries, this region grew slowly, accommodating royal courts and colonial bureaucracies. It was an environment designed specifically for horses, carriages, and localized foot traffic. A geographic layout engineered for emperors and colonial administrators physically could not support the rapid movement of millions required by a 21st century modern economy. This table tracks the demographic explosion across the region. We see the population spike from 1.74 million in 1951 to nearly 17 million by the 2011 census. Over 6 decades, the growth rate consistently hovered above 50%. That human density immediately translated to vehicular density. Delhi quickly accumulated the highest concentration of registered motor vehicles among all Indian metropolitan cities, outpacing Mumbai, Calcutta, and Chennai. By 2020, 12 million vehicles packed the roads. Planners project that will hit 15 million by 2025, with 84,000 registered in January 2026 alone. The physical result of millions of combustion engines idling in gridlock was an environmental collapse. The city began to disappear under a heavy blanket of toxic air and constant noise pollution. Left to its own momentum, the mathematical reality was clear. The capital was on track to suffocate under its own unregulated expansion. To prevent total gridlock, the local government commissioned a feasibility study in 1990. The objective was to design a fully integrated multimodal mass rapid transit system from the ground up. By 1995, they had formed the Delhi Metro Rail Corporation, or DMRC. Operating under the Companies Act, it was a specialized administrative entity built exclusively to execute this massive infrastructure blueprint. This slide outlines a crucial administrative decision. To build fast enough to outpace the congestion, the project needed to bypass traditional red tape. The Ministry of Environment, Forests, and Climate Change issued notifications explicitly exempting the metro from standard, time-consuming environmental clearances. That streamlined approach paid off. In December 2002, the first rapid transit service in the city formally launched, running along an elevated track between Shatara and Tis Hazari. Activating this single line provided an immediate physical release valve for the thousands of commuters trapped in the surface-level pressure cooker. But a single route wouldn't solve the broader crisis. The DMRC had to scale its network faster than the population was growing, executing the construction in rapid, overlapping phases. This map details the foundational expansion. Phase 1 laid down the initial 65 kilometers of track, and Phase 2 nearly doubled it, adding another 124 kilometers to connect the core districts. Then came the exponential explosion of the grid. As we see in this updated schematic, Phase 3 pushed almost 160 kilometers of new lines deep into the suburbs, while Phase 4 projected another 115 kilometers to complete the metropolitan web. As of January 2025, the system operates across 395 kilometers of track. By the end of 2026, with the completion of Phase 4, that footprint expands to nearly 450 kilometers, linking 289 stations across 12 distinct lines. Through aggressive, phased construction, the DMRC successfully engineered a transit network large enough to physically rewire how millions of citizens traverse the region. Building hundreds of kilometers of rail cost billions of dollars. To evaluate if that investment actually works, urban planners rely on strict cost-benefit analysis. One primary metric is passenger time savings, modeled by the equation T equals D over SC minus D over SD. By measuring total travel distance against the slow speed of congested traffic and subtracting the faster metro speed, analysts quantify millions of productive hours returned. That recovered time translates to physical resources, measured by the fuel consumption formula, FC equals A times the difference of inverse speeds plus B times their squares. Simply put, moving commuters onto trains slashes fuel burned by idling cars. This infrastructure functions as a massive economic engine, paying continuous, calculable dividends in unburned fuel and recovered human hours. those calculated fuel savings directly drive a measurable recovery in the local environment. To maintain ecological balance, the DMRC enforces strict water quality surveillance, monitored by independent certified labs. The local forestry department also steps in to review large-scale afforestation efforts 4 times a year. Simultaneously, project planners deploy regular medical checkups and epidemiological studies across all construction sites to ensure the infrastructure doesn't physically harm the workers building it. The payoff for years of disruption is physical. Pulling millions of passenger trips out of combustion vehicles clears the suffocating particulate matter from the sky. By providing a clean, high-speed alternative to surface gridlock, the modern rail system serves as the cardiovascular network that keeps this ancient